Let's take a look at problem 1 on the practice final for Math 141. So it's a graphing question. It says, sketch the graph of the following functions. Okay, label axes, x-intercepts, y-intercepts. Okay, blah, blah, blah. Alright, so let's just start with the first one here. So you can see that this is a definition by cases, right? So I could verbally explain what that means, but it's better if I just get right to drawing a picture. So let's let these be the axes. Alright, and you can see that something's going on here with 0. So what this is telling you is that to the left of 0 I'm going to be graphing this line. Okay, so what is this? This line is a line of slope -2, right? This is telling you that the slope m is -2. And this is the y-intercept here, and it's telling you that the y-intercept is 1. So to draw that, I'm going to make a little, it's an open circle because at 0 we're actually going to be down here in this bottom case, right? So strictly less than 0, and I make a little open ball for that reason. And now what do I need to do? From here I need to draw a line of slope -2. So what is that? That's like a fairly steep line like that, alright? So that's the first part here, and I guess I should label my y-intercept here, so this y-intercept is 1. Alright, and so this first part is done. And let me pick up again on this other thing. Okay, so this tells us what to do after 0. So this just says when I'm on the right side of 0, I'm going to pretend like I'm this function. So how do I make sense of this? Well, I just think of it as a line just like the other one. So this tells me that m is 7 because the slope is always the thing that's multiplied times x. And what could the y-intercept be? Well, I'll think of it as being like 7x plus 0. Okay, and so the y-intercept is the thing that's added, so this tells me that the y-intercept is 0. And I can make a big solid ball here because of this equal sign. And so what do I need to do now? I need to take off at a slope of 7, which is very steep. So I'll just draw something like this. I don't like that line, I'm going to do it again. So something like this. Okay, so much steeper than the line of slope 2 there. And I'll put some arrows here to let you know that it goes on and on and on and on. And I guess I should label that other thing. So I will call this 0 because that's what it is. And this is it. Okay, so we just did A. Great. So it's done. Let's see what happens if I do this. Oh, sorry, that's not the one I want. This thing. Oh, brilliant. Okay, alright. So let's go on and take a look at B here. And so what's going on with that? Oh my gosh, we're so lucky. What could be easier than graphing tangent? We practically got tangent printed on the back of our eyelids. So, okay, so let me just start off drawing one period of tangent. So as you know, or as you can figure out from the definition looking at a unit circle, the period of tangent is from pi over 2 to negative pi over 2. Okay, so in particular, one period of tangent is just pi, right? That's how long one period of tangent is. All right, and maybe I'll put some weird lines here because I'm going to have some asymptotes, right? Sorry, could draw that better. So I'm going to have a vertical asymptote for tangent there and a vertical asymptote for tangent there. And now I'm ready to just draw tangent, and we know that it's curvy. We know that it looks kind of like an S, right? Or I don't know why I said that exactly, but it's curvy and an S is curvy, so in that sense it looks like an S. But it looks just like this, okay? So it comes down here and goes down this vertical asymptote like that. Alright, so not bad. The only thing is, this says that I'm supposed to graph it on the domain from negative pi over 2, which I have here, all the way over to 3 pi over 2. So where is 3 pi over 2? Well, if I start at pi over 2, that means I go a whole another pi over to 3 pi over 2. Okay, and so it's just asking me to draw 2 periods. So let me add the second period. Whoa. Okay, so here's the second period of tangent. Oh, shoot. Okay, so turn this thing off. And it goes like this. Alright. Brilliant, amazing graphing work. Okay, and so that's it. That's the answer to B. And now let me use my scroll pushing tool and push the scroll down, and we can look at this, C. Okay. Alright, so C is also very easy because it's asking us to graph a quadratic, and so a quadratic graphs as a parabola, right? It's going to look like a parabola, something like this. Actually, it's going to be facing the other way, right? Because parabolas that face downwards have negative leading coefficients, but this one has a positive leading coefficient of 3. So it will actually look more like this. And how am I going to find where it is with respect to the axes? Well, I know that the vertex of the parabola is at hk, where h is minus b over 2a, and k is just f of h. Alright, okay. So now we just need to sort out what these things are. So what is h? Well, b is minus 1, so it's just going to be 1 on top. And okay, so 2a is 6, so h is 1/6, great. And now what is k? K is 3 times 1 over 36, because I'm just putting 1/6 into this function for t. Okay, and so minus 1 over 6 plus 3. Okay, and now bear with me now while I figure out what this is as a fraction. This is going to be 1 over 12 minus 2 over 12 plus 36 over 12. Okay, and so what is that? This stuff is all equal to, so k is 35 over 12. Alright, and so let me put some axes here. I'll turn on my hand steadying tool. There's a y-axis, there's an x-axis, and what are we looking at? We're looking at h equals 1 over 6, so we'll call this 1 over 6. Okay, and we know that k here is 35 over 12. So what is that? That's pretty close to 3, isn't it? So we'll say here is 35 over 12. And so let me just put a little dot here. Okay, so this will be where the vertex of the parabola is. And we've already said that because the leading coefficient is positive, it's going to be an upward facing parabola like this. Okay, so only one thing left to do is to find the y-intercept. So we know that finding the y-intercept of any function is just like plugging in 0. And so when you plug 0 in here, you obviously get 3. Okay, so very good. Excellent job. Let's see how we're doing on time. So I have been talking for 539 seconds. Okay, fine. That's less than 10 minutes, right? Okay, and so push all this stuff down with the right tool. There it goes. And I have to graph this polynomial d. Okay, so here's d. Let's take a look at it. Alright, and so here are the axes. Y-axis, x-axis. Let's use some more exciting colors. Okay, so let me load my program into my head that tells me how to graph polynomials. It has to do with end behavior and roots, right? So first I find the degree, and the degree I get by adding up these multiplicities. So the multiplicity of this first factor is 1. The multiplicity of this second factor is 2. The multiplicity of this last factor is 3. So the degree of this polynomial is 6, and that tells me that its end behavior is basically like this, right? Because the leading coefficient is positive and it's even degree. How do I know the leading coefficient is positive? It's going to come from multiplying all these x's, and all of them are positive. Okay, brilliant. And now, so what do we need to do? We need to also use the information about what the zeros of the polynomial are, because that tells me the x-intercept. So this is telling me this first term here says that 0 is going to be an x-intercept. This next one tells me that 3 halves is going to be an intercept. There's 3 halves. And this other one tells me that -1 is going to be an intercept. Okay, and now I'm ready to start drawing. Alright, and remember the multiplicities also tell me whether to bounce off or go through. So this is an odd multiplicity, and that means go through. So I'm going to be coming down like this, and I'm going to do a little cubic sachet through -1 because this is a cube. Alright, and I'm still going down. I have a date with my next x-intercept there at 0. Okay, and now I have to touch my last y-intercept, but for this one I bounce off like a little parabola because this little square is telling me how to behave around the root. And so off I go, and since 0 is an x-intercept, it's also the y-intercept, and my picture is done. And my solution is amazing and excellent. And that's the end, right? That's all we had to do.